Good morning, students. I am Dr. Kartik Rao. Welcome to my channel, Organ Chemistry with Dr. A.K. Rao. So this is exclusively for CSIR and NET. In our topics, today I am going to deal with mass spectroscopy. So in this topic, the mass spectroscopy, today or in this session, I am going to discuss you about the introduction and instrumentation part. So the mass spectroscopy deals with the structure of a compound. As we all know that we need to get the structure in order to identify its properties. We have to first find out the structure of the compound. In order to get a structure of a compound, it is very essential to know the mass of the molecule. So what is a mass? Simple. A mass is also called as weight of any particle or anything present in the universe. As we all know that we have some mass or weight. In the same way, atoms also has some mass. So we can see that every atom, or we know that every atom is made up of neutrons, protons and electrons. But the electrons doesn't have any mass. Therefore, only protons and neutrons will give the mass to the atom. So what is the mass of a proton or a neutron? It is approximately 1. So if you see that it is approximately 1, that is 1.67 into 10 to the power of minus 27 kg or 1 mu. Okay, so this is taken in atomic mass units. So if you see an atom, it has mass number that is given by number of protons plus number of neutrons. That is collectively called as mass number. It is denoted on the upper right corner or upper left corner of the element. That is symbol. If suppose we see a sodium symbol here. Here the 23, it denotes the mass number. So where does this 23 come from? It is the number of neutrons and number of protons. That is collectively called as mass number. In which 11 are protons and remaining are neutrons. But the difference, that is mass of the atom, is different, so slightly different with the mass number. It is almost equal to the mass number, but very slightly different to the mass number because of this 0.00 units. So it gives the mass number and mass, atomic mass are almost equal. So what about the molecule? If we see a molecule, the molecule is made up of atoms. Therefore, the mass also of a molecule or atomic, the molecular mass of a molecule depends on the atomic mass. That is, the sum of the atoms or sum of the atomic masses of individual atoms present in a molecule will give the molecular mass. Okay, if we see an example, say there is methane. See where we have 1 carbon and 4 hydrogen atoms. So 1 carbon, this carbon has 12 grams of mass, whereas hydrogen has 1 gram. So addition of these two, suppose the hydrogens are 4, therefore 4 grams plus 12 grams, that will give the 16 grams per mole. So this is the mass of the molecule, that is methane, or molecular weight of a methane. Likewise, we can calculate any number of molecules present in the universe. If we see another example, that is carbon dioxide, it has 44, which denotes the carbon and oxygen's molecular weights. So we can calculate any number of molecules in the universe by using the molecular mass formula. So we have to know first the molecular formula of the element, then only we can calculate the molecular mass of the molecule. So first know the molecular formula, then calculate the molecular weight by using the atomic weights of individual atoms. This is how we do. This is the theoretical prediction of the molecular weight or molecular mass. So, but how to detect a molecular mass of a molecule in practical way? Is there any procedure for calculating the mass in a practical way? Yes. Indeed, we have a procedure or we have a particular instrument for calculating the mass in a practical way. That is the mass spectroscopy. So the instrument look like this, where the instrument is very typical and has very complex structure. So we don't know how it look like inside. So we have to analyze this mass instrument, or we have to get in detail to the mass instrument. So we will go to learn the mass instrument in the next slides. So what are the advantages of mass spectroscopy? Is there any advantages, sir? Yeah. Yes, of course there is very good advantages in mass spectroscopy. This is the only technique which will give the accurate and reliable predictions, a reliable method. Why? Because every molecular formula will have the molecular weight, exact molecular weight. That means the molecular weight can never be changed. We cannot change the molecular weight of a molecule. Therefore, if the molecular weight is exactly matches with the molecule, then we can predict the molecular structure of the molecule. That is very accurate way in prediction of the molecular weight. So this technique is a very sensitive and specific in detection of the molecules. This is also very useful for detection of small molecules to the large molecules. The small molecules like methane, we can detect it, and also large molecules like drugs, proteins, natural products, everything we can detect in the mass spectroscopy. This is also a very good method for measuring the isotopes. That means we can also cleanly take the isotopes. Okay. So these are the advantages of mass spectroscopy. So next we will see the basic principle of the mass spectroscopy. So what is the principle behind the mass spectroscopy? In mass spectroscopy, what we do is, the molecule is first ionized or converted into positive charge. The molecule is first converted into positive charge. Then it is, you can see that the basic principle of mass spectroscopy is first convert the molecule into a ion or a positively charged species, where we can collect the mass spectrum by detecting it with the help of a mass analyzer. There are a few techniques which convert the molecule into ions. We will see it in the later slides. So then the mass to the charge ratio is converted and it is detected in the detector. So this is how we do in the mass spectroscopy. So what is the mass to the charge ratio and what is the how the ions are formed, we will see in the later slides. So what is happening in a mass spectroscopy? The first we bombard the molecule or the sample which we take with a high energy source, such that the molecule will release an electron. That means one electron is released outside. This electron will carry an electron which is been bombarded with. Therefore, what happens? It forms a molecular ion, that means a positively charged species. This is the molecular ion which is having a positively charged species. So this molecular ion with positively charged species is detected or analyzed by the mass analyzer and then detected in the detector. This is what we do in a mass spectroscopy. It looks like very simple, but a very complicated procedure is involved in mass spectroscopy. So we will see a detailed instrumentation part of the mass spectroscopy. Okay, so first let us know the layout of the mass spectroscopy. So layout of a mass spectroscopy contains only 4 main parts. Only 4 main parts. They are simple, that is, first one is sample inlet, where we introduce our sample or the molecules which we are going to detect. Then the sample is introduced into the ion source, where the molecule is converted into the positive charge ion. Then these ions will be analyzed in the mass analyzer, where the mass of the molecule is analyzed. Then it is sent into the detector. So the detector will detect the mass which is ionized here, which will give in a mass to charge ratio. Because it is an ion, it gives a charge. Therefore, it will detect the mass to charge ratio and will be recorded in the mass spectroscope, the mass spectrum, in like this. Okay, this is the spectrum which we can predict. So if we see the instrumentation, that means the cross section of an instrumentation, it looks like this. So you can see that there is a bend shape. Why this bend shape we will discuss in the later session. But see, if you see here, the 4 parts which I have seen, which I have shown you in the previous slide, are presented here. The first one is a probe, where we can insert our sample, that is the sample inlet. This is the sample inlet. Then the sample will go into the ionization chamber. This is the ionization source, where it will be converted into molecular ions. Then the molecular ion will enter into the analyzing part, that is the mass analyzer. So here the mass analyzer will be in a bend shape with a magnet present here. Why this type of structure we will see in the analyzer part. So the molecular ion will travel along the mass analyzer and will reach the detector. The detector will sense the mass analyzer mass of the molecular ion and records as a spectrum. This is what is going in an instrument of a mass spectroscopy. So we will see in detail of each and every part in the mass spectroscopy. So the first one is sample introduction or a sample inlet. Okay, simply a sample inlet. A sample inlet will look like this. That is, it has a simple probe. A probe which is used for sending the sample inside the ion chamber. So the ion chamber will receive the molecules or the sample through this probe. It has a tip which maintains the constant flow rate of the molecule, such that the molecules will be in a same flow rate. That means they will constantly go into the mass analyzer, ion chamber in a constant flow rate. Therefore, to assure that all the molecules will get the ionization, we have to assure that all the molecules which we are sending, or all the sample which we are sending through this probe, should be ionized in the ionization chamber. Therefore, the constant flow rate and a constant speed of the molecule should be maintained. Therefore, it is maintained by this tip. And this probe is attached to a reservoir where the sample is taken inside. So the sample may be a gas, may be a liquid or a solid. Whatever it may be, it should be first converted into the vapor state. That is, a vapor state should be converted. That means only vapors are sent into the mass analyzer. So for this, if there is a volatile liquid or volatile vapors, then it is directly introduced into the ion chamber by this probe. No problem. But if it is non-volatile or if it is a solid, we have to first convert it into the vapor state, then it should be sent into the ion analyzer. So for this, there is an oven, so which is vacuumed. So you have already seen in the previous slide that there is a vacuum in the in the sample analyzer. So this vacuum will develop the pressure or required for the conversion of the solids or liquids or the non-volatile liquids into the vapor state. Okay, then there will be a pin at the probe which assures the constant flow rate of these molecules into the ion chamber. So nowadays, a modern technology uses the GC, that is gas chromatography, which is attached to the mass spectroscopy, that is called as GCMS, or liquid chromatography attached to the mass spectroscopy, also called as LCMS. So these two are the modern techniques where the gas chromatography already converts the molecules into the gas form. Then it will send the molecules by one according to the separation. So there will be a separation of the molecules as well as detection of the molecules by using a mass spectroscopy. So both can be done by using this spectroscopy technique. So chromatography linked with the mass. So the same thing in the HPLC also. So HPLC will separate the molecules individually and then send the molecules into the mass spectroscopy. This is the modern techniques. So now we will go into the ionization method. So what happens in an ionization method? A molecule, that is a M, is passed through a high energy source. This energy source may be ions, may be electrons, may be neutral molecules, or may be a photons. Whatever it may be, it is a high energy source which is radiated or which is bombarded to the molecule through the energy source. Then what happens to this molecule? It will immediately release an electron outside. So electron will be released outside. What happens when an electron is released from a molecule? It will have a positive charge. Okay, so single electron is released, therefore it is a positively charged radical, that is a radical cation is formed. Okay, a cation with a radical is formed because only one electron is released from the molecule. One electron is emitted out from the molecule. It is forming only a single positively charged radical. Okay, so this is what is happening in ionization chamber or ionization methods. So there are so many methods involved in the ionization process, but initially we have only three good methods. First one is ionization source, second one is desorption ionization technique, third one is spray technique. So in ionization source we have again electron ionization, chemical ionization. In desorption technique we have secondary ion mass spectroscopy, fast bombardment, atom bombardment, that is FAB. Next, matrix assisted laser desorption ionization, that is MALDI. In spray technique there are two techniques, that is electron spray and thermal spray. So these are the different ionization methods involved for the ionization of this molecular ion, or this molecule into the molecular ion, so which contains a single positively charged species. So for this process it is very headache that which type of technique is to be used. Depending upon the molecule or depending upon the sample we use, we choose the technique. The ion source technique is the oldest method, whereas the spray technique is the latest development. So we will see one by one each and every technique in detail. Now the first one is electron ionization chamber. Before we go into the electron ionization method, we will see the ionization chamber. So this is the typically ionization chamber, which contains an inlet where the sample is coming from the probe. So there is a slit here. It ensures that a constant flow rate will be maintained. Then here you can see a filament where some energy is passed through this. Okay, so this is the where the ions are there. This is where the different techniques, different ionization techniques differ. Some may be different techniques are there. So some are electrons, some are ions, some are neutral molecules, some may be light. So different source of energy is used here. That means depending upon the ionization method, we use different sources. So here whatever the particles, whatever the energy is coming out, it will collide with the entering molecules. That is, here the molecules are entering from here. It will collide with the molecules and an electron is released out of the molecule. So electron is going to release out of the molecule. Then the molecular ions will be going into these chambers. So these are called as acceleration plates. So acceleration plates are present in the ionization chamber, where the acceleration plates, what is the use of these acceleration plates? These acceleration plates ensures that the molecular ion should not be collided, or molecular ion should not be fall. The molecular ion which is formed by the collision of the ions will have very less lifetime. That is about 10 to the power of minus 5 seconds. That is very less lifetime. If it is lesser than the 10 to the power of minus 5 seconds, what happens? It will be collapsed or it will be degraded into small fragment molecules. If it is above 10 to the power of minus 5 seconds, what happens? It will travel to the mass analyzer. For this, we have to push the molecules into the mass analyzer, which is done by using these acceleration plates. So these acceleration plates, what they do is, they will accelerate the molecular ions to go into the mass analyzer. So they will push the molecular ions to go into the mass analyzer. So for that we need the mass acceleration plate, and there will be slits for passing to the mass analyzer. That means they should be go in a constant flow rate and constant direction. So ensuring that one, we have the slits and acceleration plates. The first, we will see what happening in this filament. So if we take the electron ionization, so the first method, that is electron ionization method, what happens from this filament? It releases electrons. These electrons contain high energy source. That means they are heated to several degrees of Celsius, where the electrons are emitted from this filament and collide with the molecules. Suppose these are the molecules. When electrons are entering into this chamber, they will collide with the A and releases out, this A will releases out one more electron and forms a positively charged species. This is called as molecular ions. So why this is happening? For every molecule, there is a certain energy where the electron will be released out. This energy is called as ionization potential of that molecule. Suppose the ionization potential of the molecule is less. What happens? Less amount of energy is required to take out an electron from the molecule. So for an organic compounds, the energy is between 5 to 8 to 15 electron volts. So only the range of energy which we require to eject an electron from an organic compound is 8 to 15 electron volts. But we give almost 70 electron volts of energy to assure that all the molecules will have complete ionization. Okay, we use a high energy because all the molecules should be collided with the electron and assure that all the molecules are converted into the molecular ions. Without that we have, what happens, there is a trap here where the non-collided molecules and the electrons will be collected here. So we can see that here anode is present. Okay, so here the electrons will be collected. So this is what happens in an electron ionization method. So electron will collide with this is the most useful method, most regularly used method, and this is the oldest method. So the next method is chemical ionization, where first the chemical are a methane, butane, isobutane or methanol, some molecules like ammonia. These molecules are first heated with an electron, like previously discussed electron ionization. The methane is heated with an electron to form a positively charged species, where it again forms a positively charged species like CH5 plus and C2H5 plus. These molecules then collide with our molecule or the molecule or the sample to form the M plus H or M plus 2 C2H5 plus ions. So there is a proton transfer here. Okay, so the proton transfer will take place to form a positively charged ion. In ammonia, the same process is involved, where the electron hits the ammonia first, then the molecule will be converted into a M plus H, that is a proton is attached to the molecule. It's the same in butane, isobutane. So these are the different methods used. Then the new technique, the second technique is called as desorption ionization technique, where we use the three techniques are involved in this. First one is a secondary ion mass spectroscopy, next fast atom bombardment, and last one is matrix assisted laser absorption ionization. In these three techniques, the commonly used thing is matrix. So we can see first one, that is a sample first. Okay, our sample which is taken is dissolved in a matrix. Okay, there is a bulk of matrix present in the chamber. This matrix contains our sample, where the sample is heated with the ions, beam of ions, which has 1 to 10 to the power 10 Kelvin volts. Okay, so these are the energy which we heat the molecules. Then what are the ions taken is Ar plus and Cs plus. So in the fast atom bombardment, we take in neutral atoms like argon and xenon. So with the high energy neutral atoms, we heat the sample. In matrix assisted, we take laser beams of high intensity like nitrogen laser, which has 337 nanometers, or a photons of light is used for the heating this matrix. So we can see here that the matrix is a white balls, where we have introduced our sample like a black balls. So the black balls are our sample and the white balls are the matrix. So the matrix is having our sample inside, which is ionized or which is heated by the either ion source like in SIMS, later neutral molecules like FeB, or it may be a photon of energy like nitrogen or the laser beam in MALDI. Okay, what these three techniques do, they will hit the matrix, which pushes the molecules or which pushes the sample outside the matrix. So there the proton is heated, or proton, whatever it may be, the technique used, the SIMS, FAB or MALDI we use, they hit the matrix, where the matrix will eject the molecules with the proton transfer. The proton is transferred to the molecule inside the matrix, and what happens, they will be ejected outside the matrix. So here, this is what the technique is. So we need a matrix which will transfer a proton. Therefore the matrix used here is having a proton. That means either it may be alcohols, which is used in SIMS and FAB, or it may be acids, which are used in MALDI techniques. So these are the different types of matrices which are used in the desorption technique. It may be a SIMS, it may be a FAB, it may be a MALDI. These are the latest techniques which are used. So the next technique which we use is spray techniques. So in spray technique, we bombard or we collide the molecules with the spray of electrons. So like a spray, we just spray electrons onto the molecules. So molecules, where it come from? Capillary tube. So there is a capillary tube where at the tip of the capillary is heated with the help of the electricity. So high voltage is applied to the capillary where the tip is heated. This heated tip will slowly release a bubbles of the molecules with a charge. These charged molecules is then heated by the using either electrons or thermal. Okay, we have two types of spray techniques. One is electron spray technique, another one is thermal spray technique. Either we can use an electron spray technique when the bubbles are ejected out from the capillary. We spray the electrons to the capillary tube where it hit the bubbles and releases the positively charged electrons into the or ions into the or the molecular ions into the atmosphere. So this is the technique used in the latest, that is in in GCMS and LCMS. So the other techniques are also present which are again in a trial versions are which are in to be coming in the further generations. So that is, one is DESI. It uses both the desorption as well as the spray technique. That means it uses a matrix as well as the spray. So both combinedly they will give the better ionization method. So in this way we have different ionization techniques. So now we will see what the ionized chamber will produce the ions or molecular ions in the ionization chamber. So we got the molecular ions or the ions in the ionization chamber. These has to be accelerated. This is taken care by the acceleration plates which are present. Already we have seen that acceleration plates in the ionization chamber. So these two acceleration plates will ensure that the molecular ion will pass to the mass analyzer. So mass analysis is done in the mass analyzer. So for the mass analyzer, this molecular ion has to be travel into the mass analyzer. That they should be forcefully passed into the mass analyzer. That they have to push, or otherwise they have to accelerate it. So the acceleration ion, what they will do, their work is to accelerate the mass the molecular ion. So now the molecular ion reaches the mass analyzer. Here in mass analyzer we analyze the mass of the molecular ion by certain methods. So for analysis of this mass, these should be travel for a certain distance. So for this traveling there are different techniques. There are majorly 4 different techniques. First one is single focus, second one is double focus, third one is quadruple, and fourth one is time of flight. So first one is single focus, double focus, 4 times, and the time of flight, last one. So we will discuss each and every in detail. First we will look after the what is happening here, why this mass analyzer should have a curved path. So for an acceleration body, that means accelerated molecular ion,
where it has some kinetic energy that is denoted by half mv square. So where it is the potential difference between the acceleration plates. So this mass analyzer or these energied particles will be deflected or will have a curved path in the magnetic sector. So the magnetic sector curved path is denoted by R is equal to mv by zb, there where b is the magnetic moment. So by these two equations we can get the m by z value. So what happens here, from the ionization chamber, the molecular ion enters into the mass analyzer where the mass is analyzed. So for this we need a magnets, high energy magnets. Why? Because the mass to the charge ratio, here the mass to the charge ratio is depending upon the magnets. So square of the magnets, that means how much the energy, how much the magnetic moment is there, that means more magnetic moment is there, then the more the mass to the charge ratio is detected. So likewise, if we take a bigger magnet, what happens? The radius is also increased. It will take the curved path. Okay, so radius is also directly proportional to the m by z, and the b square, that is also proportional to the m by z. Therefore, the mass to charge ratio is directly proportional to the magnetic field as well as the radius of the path. Therefore, the magnetic analyzer is in curved path. Okay, if the magnet has less magnetism, what happens? The small molecules will be, or the bigger molecules will take a different path and will collide to the walls of the magnetic analyzer. So the curved path, what happens? The small molecules and the larger molecules will collide onto the walls of the magnetic analyzer. Nothing that they will not be detected in the detector. Only the mass which is suited to this magnetic moment will reach the detector. That means we should apply the magnetic moment, or we should constantly change the magnetic moment such that all the molecules should pass into this detector. So this is the difficulty where we face in the single phased ionization. So for reducing this difficulty, a double focusing mass analyzer has been introduced, where an electronic sector is introduced in between the magnetic sector and the ionization source. So from here, the ions will pass into the electronic sector, where the full energy of the energy of this the acceleration moment of this molecular ion is increased by this electronic sector, such that all the molecular ions will go into the magnetic sector and will be detected in the detector. So this is called as double focusing magnetic mass analyzer. So there are two, that means one electronic and another one is magnetic sector. So here this will travel. Suppose if we see this one, this is the small molecular ion which is going to be deflected in this, but due to this electronic sector, it will also again accelerated and passes to the magnetic sector, where it reaches the detector. So we have double focusing. Therefore, ensuring that all the molecules, even though the high energy or the low energy, they will all pass into the magnetic sector with a constant rate, and then they will be detected in the detector or collected in the detector. So this is how we can do the analyzation part. So the advanced technique, that is quadruple. So here we take 4 poles, that means 4 rods, iron rods, or 4 rods are taken here, where 2 are oppositely charged, these 2 are oppositely charged, and these 2 are oppositely charged rods. And for these rods, we pass the DC current, such as electronic current, and the radio frequency, where we have the magnetic moment. So both are applied on these poles. So what happens to the molecular ion now? This molecular ion, when enters into the quadrupole setup, it will take a zigzagged manner or a corkscrew. That means it will revolve like a corkscrew. Okay. So this corkscrew will go to the detector and then detected by the detector. So if there is any obstacles or anything that is not recognized by this one, that will collide onto this quadrupole setup. So otherwise, all the molecular ionization ions will be accelerated and be sent into the detector by this quadrupole setup. So this is the latest technique where GC, MS, and all the modern instruments are using this one. So the next one is time of flight. So what is this time of flight? We all know that small molecules will come fast than the bigger molecules. Or otherwise, if we have 2 balls, on my right hand side there is a small ball, on my left hand side there is a big ball, and I am throwing these 2 balls in the same velocity. That means I am throwing one bigger and smaller ball with the same velocity. I am accelerating these 2 balls with the same velocity. Which will reach first? The smaller will reach first because it is having lesser mass. The bigger will reach later because it is having more mass. The same technique is used in the time of flight, such that all the molecules from the ionization chamber are accelerated with the same velocity or the same energy. So all the molecules are given the same energy. What happens? The smaller molecule which is having a small mass will reach the detector first, and the bigger molecule which is having larger mass will reach the detector last. So this is the technique which is used in that time of flight mass analyzer. This is the best and accurate way to detect the mass, to analyze the mass. So what happens now? We have passed our sample from the sample inlet. Then the sample is passed from the sample to the ionization chamber, where it got ionized, and then it was converted into the molecular ion which has a positively charged. Remember that only the positively charged species are going to be detected in that detector. So these positively charged species are then analyzed in the mass analyzer. They are accelerated such that they reach the detector. So the detector will collect all the positively charged molecular ions, fragment ions on the species which are getting into the detector. Only the positively charged species are detected in the detector. So remember that the only positively charged species are detected in the detector. So in the detector, what happens? There is a multiplier. Suppose we are passing 1000 molecules or 100 molecules from a sample. What happens? Only 50 molecules get ionized. Remaining 50 will be collided in the ionization chamber itself. So only 50% of the molecules are converted into the ion species. These 50% molecules then reach the mass analyzer, where some of the ions will be converted into fragment ions. The remaining 25 molecules will reach the detector. So only 25% or 10 to 15% of molecules will reach the detector. So out of 100 we reach only 15 ions. The mass in the detector. So there should be a multiplier such that if only one molecule has collided this analyzer, what happens? This will be multiplied. So this will be doubled. So suppose only one ion is colliding this multiplier, it will be doubled, next 4 times, 8 times, and so on. And the output which is getting out of the detector will have multiple of ions. Okay, from 1 to many. This is what the multiplier or the detector do in the detection part. So the ions which are coming out of the mass analyzer will be multiplied in the detector and will be recognized by the detector in multiples. So the outlet of the multiple will have a recorder. So the now recorder works as a simple recording as a graph which is represented like this. In this graph we can see that the x-axis will have the m by z ratio, that is mass to the charge ratio. So what is this mass to the charge ratio? So we are taking a mass of the molecular ion. So molecular ion will have the charge, that means a positively charged species. So we are detecting positively charged species. Therefore, we recognize here the charge. So suppose a molecule is hitting by an electron and only one electron is released out. So what is the charge of this molecule? It is 1. Therefore, the Z is the 1. So the mass of the simple molecular ion will be the total mass of the molecule. So the whole mass will rely on this mass to the charge ratio. Okay. So simply the molecular weight of the ion will be its mass, because the charge is 1. Okay. So it is the mass to the charge ratio, the x-axis, and the y-axis is the abundance, that is the ratio of that is the percentage of abundance. That means it is 100%, 80, 50, and so on. Suppose a molecule is detected as 100%, then it means the fragmentation ions or the molecular ions, or it may be a fragment ion, it will be the percentage of this 100, that means 20, 30, 40%, etc. etc. So this is the abundance and this is the mass to charge ratio. So this is how the recorder will record the spectrum and it will be given as a spectrum. So here we have to know that this mass spectroscopy, even though it is termed as a spectroscopy, but it is not a spectroscopic method. Why? In the whole thing we have seen now, during the whole process, we did not use any light spectrum, or we did not use any RF method to detect the compound. But in spectroscopy, what we do is we pass an EMR, that is electromagnetic radiation, to detect the structure of the to find out the structure of the molecule. There we use the spectroscopy method for the by using the EMR radiation to find out the structure of a molecule. But in mass spectroscopy, we do not use any EMR. But it is included in the spectroscopy. Why? Because it also useful for the structure of the molecule, for the detection of the structure of the molecule. So it is also included in the spectroscopy because it gives the structure of the molecule. So very important technique in the spectroscopy method. So this is how we record a spectroscopy of a mass spectrum of a molecule by using mass spectroscopy. So in an instrument pass, we have seen the sample introduction, first one. Second one is the ionization chamber. Third one is the mass analyzer. Last is the detector. The sample is introduced. Then we have already seen the principle in the previous slides, that the sample is first introduced, then the sample is converted into the molecular ion in the ionization chamber, where the molecular ion is passed into the mass chamber, mass analyzer. It will analyze the mass and can be recorded in the detector. So these are the four parts where the mass analyzer is working, is reliable on. Okay, so this is how we detect the mass in the mass analyzer. So later classes we will see the techniques, and we will see different ionization methods, different fragmentation process, and different peaks which are given in the mass, how to read a mass spectroscopy, etc., etc. Thank you for the patience listening. Thank you very much.